Hey, it's Michael, and I thought we would spend some time talking about rounding, significant figures, and decimal places. So let's just jump right in. I'm going to come up with some numbers, and we'll take a look at how we work these different problems, depending on whether we are just straight up rounding, whether we're doing significant figures, or whether we're doing decimal places. So let's get started with this one. So let's say we have 7.21 plus 93.24 minus 4.1116. Okay, the first thing we have to notice is that this is a subtraction and or addition problem. In this case, we've got both. And when we're dealing with subtraction and addition, we are concerned with decimal places. And when we talk decimal places, we need to find the number with the least amount of decimal places. Now, there are two of these, the 7.21, there are two decimal places here. And on the 93.24, there are also two decimal places, the 2 and the 4. So when we work this problem, we need to make sure that we end up with just two decimal places in the end. So let's pop up the handy dandy calculator. 7.21 plus 93.24 minus 4.116, and that comes up to 96.334. Now, as we talked about before, in addition to subtraction problems, we are concerned with decimal places. We want to have just two decimal places, and you can see we have three. There's one there, there's one there, and there's one there. So what we're going to do is we're going to take our two decimal places, so there's 3 and 3, and I'm going to go to the next place over, and I'm going to round. 4 is less than 5, so we make it a 0, and our final answer comes up to be 96.33. So the two decimal places here matches the two decimal places in the number in the problem with the least number of decimal places. So let's try something with significant figures. Sometimes I call these significant digits, and you'll hear me call them sig figs as well. They all mean the same thing. So let me throw out some numbers, and we'll work through those. So the first rule, a number like this, 886. Hope you can see that well enough. Let me change colors. So 886. So the first rule of significant figures is that every non-zero digit is significant. In this case, there are 3, they're not zeros, so that gives us 3 sig figs. All right, our next rule, we're going to expand on that a little bit. We're going to add some zeros. If there are zeros in between non-zero digits, like there are here, then we count those as well. So in our case, that's going to make 4. There's 1, 2, 3, and 4. Let's take a look at the number 0.2700. Any leading zeros, so the ones on the left-hand side, are not significant if there are no other numbers in front of them. Any trailing numbers or trailing zeros on the right-hand side of the decimal place are significant. So the 0 here is not significant. It's on the left-hand side. It's a leading 0. The zeros here are significant. They're on the right-hand side of the decimal place, and they're trailing zeros. So that's going to make us 4 significant figures there as well. So let's look at this case, 15000. So there I've got 15,000. And trailing zeros on the left-hand side of the decimal place aren't significant. So these 3 trailing zeros here, not significant. So that makes for 2. Let's see if I can think up a couple other cases we can do. 0.0027. Any leading zeros aren't significant. Now in this case up here, we had zeros in between non-zero numbers, but on this one we do not have that same case. These are just leading zeros, so they don't count, and so there's only 2. What about 15,000.1? Well, even though we've got trailing zeros here, we have zeros in between non-zero numbers. So these would count. So we would have 1, 2, 3, 4, 5, 6 there. Let's go to a multiplication problem. And let's just say we want to do 21 times 4.211. So I'll pop up the calculator. 21 times 4.211. All right, so the first thing we should notice here is that we are doing multiplication. Multiplication deals with significant figures, and the number with the least amount of significant figures is the 21. So our answer has to just have 2 significant figures at the end. So we came up with 88.431. To make this into the correct amount of significant figures, 2, there's the first one, there's the second one. I have to take a look at this third one here and round it. It actually rounds to 0. Right? So we're going to have 88 as our answer. What about, let's do a reciprocal. Let's say we want to do the reciprocal of 2.57. And if you remember, reciprocals are just 1 over. That makes this a division problem. Division and multiplication, we look at sig figs. We have 3 significant figures here. So I've got 2, let's see this. Yeah, 2.57, and I'll do the 1 over button. All right, so we end up with a whole bunch of, we got 0.3891, 0.3891. I'll just put dots here because there's a lot of other stuff. All we need are 3 significant digits. So we look at the 0 here. It's a leading 0, so it doesn't count. So we've got 3, 8, and 9 are the significant digits. We have to look at the fourth one to see if we round up. Let's just say this was a 7. Hope that doesn't mess everybody up. If this was a 7 in the fourth one, we would have to round up the 9, right? And so we would end up with 390. But we still just have the 3 significant digits. But we didn't round up. I think that was a 1. So we end up with the real answer is just 389. Let's do another one. Let's try 9.73 squared. So this is a multiplication problem. Again, we're going to be looking at significant digits. So whatever our answer is, we've got to come up with 3 significant digits because that's what we have here. 3 non-zero numbers. So 9.73 squared is 94629. 94667. Yeah, I don't remember. I'll go look. 6729. We want 3 significant figures. So there's 1, there's 2, and this is going to be the third. And we have to figure out if we're going to round or not. And this digit is a 7. So we're going to have to round up to 94.7. Because this number, 94.6729, is closer to 94.7 than it is to 94.6. All right, let's talk decimal places. Now, we use decimal places when we're talking about addition and subtraction. So if I said round this number to 2 decimal places, what would we do? So I've got 7.977. And if we want to round to 2 decimal places, we would take a look at this third spot here. And it's bigger than 5, so we're going to round this number up. So that's going to be 7.98. What about 11.845? We want to go to 2 decimal places. So we look at the third decimal place. It's a 5. Let's go ahead and round up. And so we end up with 11.85. What about something like this? 1003. So we want 2 decimal places. We go to the third to see if we round up or down. It's a 0, so we just leave it as is. And the number rounded to 2 decimal places is 1.00. Okay, so how does that compare with significant digits? We've been rounding to 2 decimal places. Let's round to 2 significant figures. So I'll put deci here. So let's round this same number, 7.99, or 977, sorry, to 2 significant figures. Well, there is the first one, there's the second one. So we're going to go to the third figure and see if we need to round up. That's a 7, it's greater than 5, so we're going to round up. That's going to make this a 0, which is going to make us round that one up as well. So 8.0 is that number rounded to 2 significant figures. Let's take a look at the next one. We have 11.845. That is 1 significant digit. There's another one. Remember, they're non-zero. So we go to the third one and we look to see whether we want to round or not. It is bigger than 5, so we are going to round up. So I end up with 12. Let's do 1.003. So we have 4 significant figures here. We need to get to 3. I'm sorry, we need to get to 2. So I get to count this one and this one. Remember, zeros in between non-zero numbers are significant. So I look to the third place. We do not round up, and so that's going to be 1.0 if we round to 2 significant figures. Now you'll notice on both of these that the number is really close to the original, where we had 7.977. Looks like we've got 7.98 up there. I'm not sure why that looks so bad. So those numbers are approximately equal. 11.845 is approximately equal to 11.85. And I say that because I've seen students want to move the decimal point, and you can't do that. These two numbers should be almost identical. And it's the same with sig figs. 7.977 is almost equal to 8. 11.845 is almost equal to 12. And the same here. All right, I hope you find that helpful. I'll recap really quickly. Anytime we are doing addition problems, we are concerned with decimal places. Anytime we are doing addition, subtraction, anytime we're doing multiplication and division, we are concerned with significant figures. The rules for significant figures are any non-digit number is a significant figure. Any zeros in between non-zero numbers are significant figures. Any trailing zeros on the right hand of the decimal point are going to be significant. Trailing zeros on the left hand side are not significant. So 15,000 could be rounded, so we don't know exactly what these numbers are. But the 27,000 that we see, 0.2700, we know we measured to that precision, so those are significant. And finally, any leading zeros. So if I put 0.0001, these are all leading zeros. That's going to be one significant figure. The same as if I put 0001 there, that would still be one significant figures. All right, I hope you find that helpful. If not, please reach out to me and we can talk more about it. So have a great day. Thank you. Bye.
All right, guys, that's a wrap.